All right, number 2. Okay, so this is another one that won't be on the AP test, and we haven't talked about, but it's the same as the one from last week, basically. Slightly different, but whatever. Product advertisers studied the effects of television ads on children's choices for 2 new snacks. The advertisers used 2 30-second ads, TV ads, in an experiment. One ad was for a sugary snack called Choco Zooties, the other for a healthy snack called Apple Zooties. For the experiment, 75 children were randomly assigned to one of 3 groups, A, B, or C. Each child individually watched a 30-minute TV program that was interrupted for 5 minutes of advertising. 3 groups of advertising: 1, Choco Zooties but not Apple Zooties; 1, Apple Zooties but not Choco Zooties; 1, neither of them. After the program, they were given the choice between the 2 snacks. The table below summarizes their choices. Alright, do the data provide convincing statistical evidence among all children similar to those who participated in the experiment? Alright, so we are doing a chi-squared test here. So let's take a second and write down the stuff we know. Alright, so the form of the hypothesis test is exactly the same. We start with hypotheses. Our null hypothesis that there is no association between what advertisements they saw and what they chose. And the alternative hypothesis, there is an association. Between what ads they saw and what snack they chose. Alright, those are our hypotheses. Our model, so random, they were assigned to random groups. And expected this one we're going to come back to in a second because we have to do it before we get the expected values. We are doing a chi-squared test. Technically, we're doing it of homogeneity here, which is different than the independence one, but it's exactly the same. So, we're going to proceed exactly the same. Alright. So, enter our data into a matrix. 3 by 2, this is 21, 4, 13, 12, 22, 3. Alright. Then, we will do chi-squared. It's in A, it'll output expecteds in B, and calculate. Alright, so let's write down all of this stuff before we go back and look at the expected. Alright, we have a chi-squared of 10.291. We have 2 degrees of freedom, and we have a p-value of 0.0058. Alright, now let's go back and look at the expected values. So this is our expected matrix. If there was no association, we'd have 18.67 choosing Choco Zooties and 6.3 choosing Apple Zooties in all cases. So are all greater than 5. Alright, so we have our p-value. You should still be able to do this even if you can't do everything else. We're rejecting the null hypothesis here. So we do have evidence that there is an association. Alright, conclusion. With a p-value equal to 0.0058 is less than 0.05, we reject the null hypothesis. We have evidence that there is an association between the commercial they saw and snack choice. Alright, that's part A. Part B, write a few sentences describing the effect of each ad on children's choice of snack. Okay, so we want to compare everything to the baseline here, essentially. The baseline, our control group, is group C, right? That's the one where they saw neither commercial. So we'll calculate each percentage and compare it to that, basically. So for B, children who saw neither ad, control group, C, saw 22 out of 25. Choose Choco. Let's see now. The Choco ad saw 21 out of 25. Choose Choco. This is what, 88%. This is 84%. The Apple ad saw 13 out of 25. Choose Choco. Which is, what's that, 52%? So, the Choco ad did not appear to make a difference because the percents are very similar. While the Apple ad did appear to make them choose Apple Zooties, because 52 is much less than 88.